Hi class, this is the last section in Module 4. I'm going to talk about how to prove parts of triangles are congruent. And we're going to use this acronym that you see at the top, CPCTC. What that stands for is it says that corresponding parts of congruent triangles are congruent. So if you're given that two triangles are congruent, you can assume that all their corresponding angles and all their corresponding sides are congruent. It's essentially like the converse of the definition for congruent triangles. So we're going to use this one to prove parts are congruent. So far we've learned 6 different ways to prove triangles are congruent. We've used the definition of congruent triangles, side postulate, side postulate, angle side angle, and hypotenuse leg. And remember, hypotenuse leg is for right triangles only. So here's our objective. In this section we're always going to still use one of these 6 methods to prove the triangles are congruent. Then we'll use this CPCTC to say that their parts are congruent. Okay, so let's do a couple examples here together. Alright, so in this section we are trying to show that angle A is congruent to angle D. And here's what we're given. We're given AB is congruent to DC and ABC, this angle right here, is congruent to DCB. So what I always like to look for is a shared side. So I do have a shared side right here. And I'll use 2 markings since we already have one on there. So it looks like I have side angle side in each triangle, which is one of my methods for proving triangles are congruent. So if I can show that this triangle is congruent to this triangle, well then A and D have to be congruent because they're corresponding parts. So let's follow this flowchart proof here. So it says angle ABC is congruent to DCB. That was my second given. The reflexive property, which is what I added down here, that shared side, was that BC is congruent to CB. And all of that information together, side, angle, side, led me to say that this triangle is congruent to this triangle by the side, angle, side postulate. So then, if the triangles are congruent, their corresponding parts are congruent. So angle A has to be congruent to angle D. Remember, last line is matching what I'm trying to prove. And my reason that I put here is CPCTC. Corresponding parts of congruent triangles are congruent. Okay? So that's exactly how these are going to look. First, prove the triangle is congruent. Then you can say those specific parts are congruent by CPCTC. Okay? Alright, let's look at another one here. So if I look at number 2, we're trying to prove that angle 2 is congruent, A is congruent to D. So this angle is congruent to this angle. So again, if I can show this triangle is congruent to this triangle, then I can say those parts are congruent. So we are given in this picture AC congruent to DB. I'm also given these are right triangles, which remember we want to look for hypotenuse leg if that's the case. So right triangles, and I've got a shared side. So I've got hypotenuse congruent to another hypotenuse, and a leg congruent in each triangle as well. So this one will work for hypotenuse leg. So I want to say that my triangles are right triangles, so that hypotenuse leg is valid. DCB are right triangles. We can say given. And then we notice that shared side, that CB is congruent to BC by the reflexive property. So I've got my hypotenuse is congruent, my legs are congruent in right triangles, so I can say the triangles are congruent. ABC is congruent to triangle DCB, and this was the hypotenuse leg theorem we used. So since the triangles are congruent, their corresponding parts are congruent. Angle A is congruent to angle D by CPCTC. Alright, number 3. Prove that AC is congruent to DC. This piece is congruent to this piece. So if I can show this top triangle is congruent to that bottom one, I can show their parts are congruent. Okay, so we start with the given. AB is congruent to DB. And I also am given a pair of congruent angles here. Angle ABC is congruent to DBC. And that's another given here. So then again, we want to find shared sides when I can, which I see that BC is congruent to BC here by that reflexive property. So what do I have? Side, angle, side, side, angle, side. That's enough to show those triangles are congruent. So triangle ABC is congruent to triangle DBC by the side, angle, side postulate. And if those triangles are congruent, then their corresponding parts, AC is congruent to DC. By CPCTC. All right, last example for this video. Explain how we would prove that angle ABC is congruent to angle DEF. So we're not going to do a full proof, we're just kind of walk through the steps. So the first thing would be to prove that these triangles are congruent. So the easiest way to do that on a coordinate grid, since I don't have any angle measurements, would be to show that all three sides are the same. So I could do that using the distance formula. So I would use distance formula to show all three corresponding, I should say 3 pairs of corresponding sides are congruent. So triangle DEF would be congruent to triangle, looks like BAC by the side, side, side. And then 3, angle ABC would then be congruent to angle DEF by CPCTC. So if we could show those triangles are congruent, we would say their parts are congruent by CPCTC. Alright guys, this is the last section for Module 4. You're just going to use the shortcuts you used from those last couple sections to prove triangles are congruent, and then you can say that their corresponding parts are congruent using our new acronym CPCTC.